Hello everyone, welcome to the Dev Method. Today we're going to get started on some iOS programming. So if you haven't been a mobile developer before, you have a couple of choices to start with. There are a couple different cross-platform frameworks and languages you can use. There's also the native languages and what's supported by essentially the manufacturers who make the products that your code is going to run on, or that your software, your app is going to run on. So I'm primarily going to deal with iOS today. So iOS is the iPhone, Apple TV, iPad operating system. And I'm going to be showing you how to write code in Swift. And we're going to be taking a look at two different front-end frameworks that Apple provides, so natively provided from Apple themselves. If I wasn't going to do that, there are other web technologies that you can use. One of them is called React Native. So React Native, if you've looked at some of the past videos, it's essentially the same idea as React for the web, and brings that over to actual like native running code on iOS. So like real looking buttons. There's definitely a difference. There's a technical difference, and there's not enough time in this video to describe all of those, but that is one route that you can go. Another route that's becoming super popular rapidly is Flutter. Flutter is actually developed by Google, and their technology uses the programming language Dart. So Dart, very similar to the other languages, it's not as used much anywhere else. I actually don't know anywhere else it's used besides Flutter, but the idea is still the same. With React Native, you write your code once and run on two devices, or two different platforms or multiple platforms. Flutter takes that same approach. Flutter is a little bit more ambitious and lets you then create websites or desktop applications too. Some of those features are not fully fledged out, and not all the features are supported yet, or all the APIs are not supported yet. But when looking at least those three, so the native world, like what the manufacturer gives you, so like with Apple, it's going to be the Swift iOS, and we'll talk about the frameworks that we use there. Then there's React Native, which is an open source project created by Facebook, and it uses JavaScript, or even some people are using technologies like TypeScript to create mobile apps that are very similar to web development. And that runs on iOS and then also Android. And then there's the Flutter part. So the Flutter, developed by Google, is also a open source project. A lot of that stuff is open source for you to look at. And the goal there is to run it on iOS and run it on Android, but then also run it as a web app, or maybe like a desktop application too. So now that you have the spectrum, those are some of the major players. There are other options out there. There's not enough time in this video to go through all of those, but if you look up at least some of those, you'll get an idea of the type of comparisons people make online. So do a quick Google search, look up Flutter, see what it's about, look up YouTube videos, see what it's about. But today we're going to primarily stick with native development, specifically iOS. So for us to get started, there's a couple of tools I want you guys to make sure that you have downloaded. A lot of this stuff that we're doing here today is free software that you can start developing on. There's going to be no cost to you. And so the first thing I want you to get is Xcode. So Xcode, provided by Apple here in the App Store. It's a free download. It's got a lot of features that help you debug. It goes everywhere from like super beginner to super advanced. And I don't know anybody who knows all the features. I think everybody has their own little area that they branch off into as being like a specialist in. There are other applications that this comes with that are bundled, like a bunch of the different simulators. But then there's a couple of great tools like Instruments, Accessibility Inspector. And these tools are to help you with all around iOS development. So that's one that I want you to download. And that one takes the longest, and then there's like an install process that has to run after you open the app, after the download. So I would do that one first, get that one going. But then another one you can use, and that we're going to be starting with today, is called Playgrounds. So Playgrounds recently released, and also from Apple, allows you to walk through getting started for coding, and a lot of this is geared toward a younger audience. So it might not catch your eye at the beginning when you look at some of the screenshots, but it is a great place to experiment and try new things. So that's what we're going to be looking at today. And the big difference that we have with developing UI or user interfaces in Swift Playgrounds versus Xcode is that Xcode has a feature for you to build your user interface, but in a more visual way, like clicking and dragging shapes and text around the screen and laying them out, and then drawing lines directly to your code and making these connections seamlessly from code to like some sort of graphical element that you see on the screen. The Swift Playgrounds is completely all code. So that's what we're going to stick with for now. And we're going to do that because of some of the frameworks we're going to be dealing with. So why don't you open up Swift Playgrounds. So this is more or less what you can get to start with. Just to get you acquainted, this whole black canvas is where you write your code. So code goes here. So the first thing to think about when you're writing your code here is what kind of frameworks you're going to be dealing with. We have two different frameworks, so we're going to go ahead and start using both of those. So there's the traditional one called UIKit, okay? And then there's also a brand new one called SwiftUI. And so UIKit has actually been around since the beginning of iPhone. So that's what you primarily would use you would develop your user interface with. If you're walking into a project that exists today, and especially if it's already been in the App Store for over a year, this is definitely something you have to be familiar with if you want to step into a professional setting with iOS. So I'm going to go ahead and say iOS 2, because that's technically when the original SDK was available, through iOS, what's the one today, 13? So that's like supported now and into the future. The new one here is iOS 13 and up. So only with iOS 13. Now, I would say if you were to go on the App Store today and look at a bunch of the apps that are popular, I don't think there's one out there that only uses SwiftUI. There's a couple reasons for that. One is that not all users are upgrading to all versions of to the latest version of the operating system. All these people's devices, they might be older, they might not know how to upgrade, they might not have enough storage space left on their device to upgrade. But the whole point being is that you want to be looking at UIKit and SwiftUI as a way of working together. So like a lot of the stuff in SwiftUI, if you're going to be transitioning to that in your projects later on, there's still reuse that you can get out of your UIKit code. It might not be necessarily what you'd expect, but that's going to be something you can definitely do. Okay, so you see here we have these two frameworks. Now the last one we need just for Playgrounds is import Playground support. Notice as I type, there are a couple of options here at the bottom to help you autocomplete. So there you go. So let's first start with UIKit only, and then we'll go to SwiftUI only. Now the biggest thing we'll see here is that there's going to be less code for SwiftUI. That's some of its goal. That's more of its intention, is that it's a lot less code for you to write. But at the same time, I think you'll see the pros and cons of one framework over the other. And a lot of it is your mental model. So the UIKit stuff we'll be looking at is more imperative. So it's one statement, programming statement after another, and therefore lends itself better for object-oriented programming, whereas SwiftUI is more declarative. So that means that you're not necessarily using classes and reference types, but you're actually using value types, so structs. So we'll take a look at the difference between these two. So the first thing, let's just do plain old view controller. UI view controller. And we need to get us set up with the bare minimum to start seeing a preview. So what I'm gonna do is override this function called load view. And all I have to do, my responsibility, is to set the view. And I have to remember to do that. So usually the way I set this up in a playground is like so. And I'll set the background color. And since I want to cater to both audiences using dark and light mode on the platform, there's actually this thing called system background. And that's just the primary background. And it will switch from dark mode to light mode according to the user's preferences. So I'll just start there. And if I was to click run at the bottom right-hand corner, I will get something to run on this. And I actually don't see anything right now because why don't I just change it to plain old red? No dark or light mode. Yeah, so there's nothing wrong with the code that's written here. But if we wanted to get to show a preview, that's where we actually need to use the playground support. So this is how I usually use that. So I do playgroundpage.current.liveView and assign that to the view controller, just like so. So we'll use the default initializer on this, this object of a view controller. And now let's run the code. Let's see what we get. There's our red background. So I just wanted to show you that so you can see what it looks like. But now, why don't we change this back to system background and tap on run code. All right, great. So it doesn't look like anything's there, but there is something there. Now let's go ahead and take some text and we'll just say hello world, the very, very stereotypical saying that we like to put on our applications that we write for the first time. And I'll write this out and I'll explain why we write some of the code in this way, because we'll compare it with SwiftUI. Okay. Now I'm just going to take the label, give it its size that comes from the default text. And I'll do center X and center Y. As you're typing through this, you might realize that sometimes your cursor doesn't move left or right the way you want it to. It's because there's a lot of auto-completing and a lot of assistance that Playgrounds is trying to help you write the code. And it's not always what I'm used to when writing code. So I already know some of these APIs. I already know some of what needs to be written just from pure memorization and experience. And it does get in the way sometimes. So you'll see if I do make a typo and we run it, we'll see some sort of red dot. So just to give you an example, I'll make a typo there. Here's our red dot saying something's wrong. And we have to read these and try and figure out what is the problem with our code syntax. Maybe it's not necessarily the code syntax, but maybe it's the wrong types. The compiler doesn't like necessarily that you're trying to take something that should be text and assign it to a variable that's expecting a number. Yeah, okay, cool. Attributed text. Let's run this. Let's see what we got. All right, it's very tiny. Hello world. I'm gonna go ahead and put some returns on here to make this look a little bit easier for us. Let's review the code that we wrote to get us to this point. So right now we have the view, which is going to be our background, that every view controller has a property on itself called view. And in this playground, this is how we're going to set it up. We're going to set it ourselves. Now it comes at the very bottom. So I guess I could put it at the top, but let's just see if that makes any difference. This is how we can experiment in playgrounds. Go ahead and say run. All right, no difference. Sounds good to me. Then we create our label, and then we add that label as a subview of the background view, meaning like we want it to be inside of it. Now we also have our layout afterwards. So this is a very common pattern that I use myself. So I do ns layout constraint.activate, and it takes an array of constraints, and then it activates all of them. If I was to create a constraint out here, for example, if I did that, that doesn't do anything. That actually doesn't set the variable. That sets the variable to x, but it doesn't activate the constraint. So then there's this is active. I need to set it to true. But in that case, I wouldn't need this as a variable. There's no return type when I set it to true. So it just looks something like this, which might be making our lines look really long. So the idea here is that this is not necessarily a shorthand, but just a preferred way of writing this layout code. So now that we've seen this, let's do the same thing, but in SwiftUI. So that's where we'll write it down here. So SwiftUI, instead of a view controller, we simply just start with views. And views are components, and those components will be a composite structure or a composition of other views. Very similar to what we just did here, where we had this view, so we constructed this. This could be our component, and then we added a label to it, and it's its subview, so it's the composition of those two things being together. And then I told it how to display on the screen. So with SwiftUI, I'll call this my view, we have a struct. So the struct is not inheritance, but it's actually a protocol, or an interface that you're meant to implement. And this is the way we write it here. So it's a computed property, and it's the body, and it returns some view. You don't have to know the exact type, but it returns something. And in SwiftUI, the closest thing we have to a label is going to be text, and we pass it a string literal. So in this case, I'll do the same thing, hello SwiftUI here. Now, how do we get it then displayed on the page? We'll do playground page.current, and then there's a .set live view, and then we give it our view here. So I'm going to comment out the other one so we don't run both of them, and just run this one here, and then run that code. All right, so now it says hello SwiftUI. This here is obviously a lot shorter than what we have up here at the top. It's not to say that the code has to be structured this way. It's not to say that the code has to be structured this way, but this is typically how I would write it because I can easily upgrade some things on here. So just as an example, if I do .font, then I do UI font, name, let's say Verdana, and the size of 24 font, okay? And let's now play just the UIKit version of the code. You'll see it's a bigger font now, and it's also a different font size. So if I went here, SwiftUI actually has font, but instead of a UI font, it's just font. And I do this dot notation so that it can have some sort of auto completion. And what I'm going to do here is just large title. And run that on the SwiftUI part. There we go. There it is. Now, I didn't change it to Verdana, but I did make the text larger. This is also part of the built-in iOS feature of dynamic types. So if you wanted your application screen to automatically scale the fonts up and down based on user settings, and therefore meeting the user where they're at with their vision, you would be able to have a larger font size here that automatically scales. So these are some predetermined fonts that you can take a look at on the Apple developer website. Maybe that's something for a later video. If you'd like to see a video like that, why don't you put that in the comments below, and we could talk all about dynamic types. So let's see here. Let's take a look at like another thing that we might want to do that's a little bit different in imperative versus declarative. So let's say we wanted to like make a box around these words, and we wanted it to be just a red box, and it's like, 200 high, 200 wide. Let's go ahead and do that. So what we would do is I would call this my rectangle. Whoop. And in UIKit, it's just going to be rectangle. And in order to do the programmatic layout, I have to keep setting this property here. It's called translate auto resizing masks into constraints. So that allows me to run this code later on and get the expected output that I desire. If I wanted to do it by frames, that could also be an option too. But then I'd have to also know the exact position, point X and Y on the screen that I want it to display. So with auto layout constraints, I'm kind of skipping some of that and going straight to more like a closer step toward declarative layout or declarative code. So you'll see in a second here. So let's do our rectangle, background color, and we'll do a system red. Okay, so it'll be a background color. Now, view.add subview, the rectangle. Okay. Now, if I was to run this code, there's actually not going to be a rectangle there yet. I got to add the size. So we'll still just see the words. But now, let's do the rectangle layout. So rectangle dot width anchor dot constraint equal to constant. So a hard-coded magic number value. So I said 200. Let me do the same thing now, but with the height. The height. So that's the X and Y, but then with auto layout and constraints, we have to also think about not only its position X and Y, but how large is it? And some of our views, like our UI label, that actually has an intrinsic content size based on the font. So the font that is set is Verdana and it's 24 size. So automatically we'll already have an intrinsic content size. But for something like this shape that we're creating, this rectangle, we have to set its exact size. So I did that now, but now we have to set exactly where is it positioned on the screen. So I'm going to do it very similarly to what we have here with the label. Just going to put it in the center. Let's run that code. All right, there it is. Very cool. Now, one thing that could mess this up is we reverse this order. So now I'm adding the rectangle after the label. So watch this here. So the label is actually still there. It's just behind the rectangle. And I'll show you how I know that. There's a great property on a UI view, and let's do like, I don't know, 0.6, which means like 60% opacity. You'll see a little bit of the text in the background there. There it is. Yeah, so it is definitely still there. Now, that order does matter. So again, we have our view, that's the background, we have our label, and then we have our rectangle, and then we have to add them as subviews of the other view, and then we also have to say what its layout is going to be. So let's do the same thing that we have here in UIKit, but now let's do the same thing with SwiftUI. So SwiftUI, if I was to say, if you think this was like adding a subview in the background or something like that, if I was to say rectangle, so I can make my rectangle. And then I do foreground color, and I do system, or actually not system, because it's color, it's not UI color. So I just do red here. It actually will not compile. It will not run this SwiftUI code. And it's telling me a function declares an opaque return type, but has no return statement. So if we want both of these things to be returned at the same time, we actually need to like group them together somehow. So it's kind of the equivalent of this view. Like, how are these things being associated together in the same area? So like, if we want to stack them on top of each other, SwiftUI has a stack that you can put it on, and there's a couple different kinds. There's a vertical stack, a horizontal stack, and then a Z stack. So the V stack is the vertical stack, the H stack is the horizontal, and then the Z stack is the one that is on top of each other. So like the Z index. So instead of just X and Y, you would have something on top of each other, so a third dimension. So that's what we're gonna do here. We're gonna wrap this in a Z stack, like so. And we'll just take this code, cut and paste it inside. So now this is kind of like the view that we have, the body. Let's go ahead and run this. No more compiler complaining to us. There we go. Now, I didn't put this part in, so let me, before I forget, let's give it a frame. That way we can set its height, its width and its height explicitly. There we go. So it should be more or less like what we had there before. Yeah, there we go. So that's the SwiftUI equivalent. Obviously a lot less code. And it's not always about just less code, but this is really manageable if we want to go back and review. Maybe our requirements change and the color has to be different. I can go ahead and update that color here, whereas I kind of have to look through all of this code here, and I don't necessarily see a visual layout of how things are organized hierarchically. And I have to imagine in my mind that, oh, okay, so the rectangle and the label are going to be siblings to each other, but the rectangle's added first, so it is actually going to be behind the label, and that's a little bit of what we're doing here. But then right after the rectangle, I see that it's color and then its height and its width, but I have to look down here somewhere else to see its height and its width. I suppose if I used frames, I can get away with that, but then I wouldn't be able to like use some of this auto layout code. So I don't want to go into my whole mind of like all these things that I'm thinking about all at once, but I just at least want to give you a taste of what's different between these. Now let's say we wanted to break these things out into components. So like I have a class, call it view component, and it is a subclass of UI view, right? In order to get this up and running, just say layout subviews is what I want, and I'll just say the background color is going to be system teal. Kind of like a close to like a blue and a cyan color. And then I want to use that in here. So instead of the rectangle, let's just say, I don't know, I'll do rectangle 2 equals view component. Now rectangle 2 translate auto resizing mask to constraints false, right? And then I already have some of its properties set up, so I don't have to worry more about like what needs to be set on this. Now I add it. So let me add it like in here. Add subview. I'll say rectangle 2. And I'll do the same thing I have here for the rectangle. And just add the 2 and the 2, and the 2, and the 2. But I'll make this a lot smaller, so let's make it 100 instead. And let's run that code. Oh, I gotta run it in UIKit, not in SwiftUI. Cool. Now, I don't mean for the text to be more difficult to read, but at least you guys get an idea of how this works. If I want to keep adding to this, this is how I compose views together to make a more sophisticated view. So in here in SwiftUI, what we do is actually we do this in a rather different way. But I guess I could, if I wanted to, just do another rectangle inside the Z stack and get the foreground color to teal. Is that an option? No, maybe cyan. No. Color dot blue. Yeah, maybe I'll just use blue for now. And give it a frame with a width of 100, just like before, and a height of 100. Okay, so that's how I could simply add that for the SwiftUI version of our code. So let's see what that looks like. Okay, so that's what that one looks like. If this was like a more sophisticated component, this thing here, like the whole thing maybe, this is what we could do. We could say struct, and I'll call this component, let's see, I don't know, let's call it my box. Okay, and it's a view. Same thing as before, body, which is some view. And what I could do is just take all of this stuff here, and the constants in this, or the thing that will be the same, is the two boxes, but you'll be able to set the outer and inner color. So let's see how we could do that. So my box, just like so, this would actually give us the same output, right? Let's say I wanted to change what the colors are. So you actually just set some properties. So I'll say outer color, which is a color, and then inner color, which is a color. Now, this will actually require that I have that constructor, which is automatically generated for me by Swift with structs. I do it here now, so I'll say red and then blue. Now I can take this one and say this is self.outer color. And then this one is self.inner color. Okay, now I'm starting to create some sort of like reusable view, because I'll change this to green. And you can imagine I can have multiple of these. So like, let's say I wanted to do a V stack and stack two of these up, one after another, and just slightly change the color variation between the two. I can do that now, and very easily start composing components together. Maybe if I want them side by side, I do an H stack here. So this type of experimentation, I think the feedback loop of you writing the code, seeing the visual output, and connecting your understanding of what the code says to what actually appears on the screen, it's a lot quicker. And that rotation from an idea to trying something out in code to building and running it, it's a lot quicker in something like SwiftUI, especially with playgrounds here. But let's say we wanted to do the same thing now with UIKit. So this is going to be that component that we talked about. So I would want to make an adjustment here to take all of this stuff. So like even the view here, let's take all of this and move it inside here. And we'll change this back to our rectangle and rectangle 2. So rectangle 2 dot background color system blue is what we had there. So this is my view component now. And then this is the view controller, the thing that's showing it. So the view controller, again, is like the my view. And then this my box is kind of like our view component here. So I got the text in there. Now the thing here is I want to do view component. So now it's view component self.view equals view. And that is going to give us what we had before. Oh, and then anywhere where it says view, I got to take that out. There we go. And then it's not view, but it's just self. So just take out some of these things here. Slight refactoring. As you can see, refactoring, I think a little bit easier to do in SwiftUI because there's just a little bit less code to deal with and to think about. So let me take out all of these. Okay. Okay. That should be all we need. Ooh, yeah. All right. So something I realize here too, adding subviews. I think we're running into an infinite loop here. It's going to tell it to lay out the subviews again because we're laying out the constraints every single time. So typically what I do, I don't even know why that was there. What I do is I make my own constructor, and I have a couple of things that I might need to create or set up about this. And for now, I'm just going to call this a private function of setup UI so that I know in the constructor it's only done once. The other thing, though, in this constructor is I think I need to do frame 0, and I think that's how I'll get that to work. Oh, yep, and because we're using UIKit, and there's multiple ways to have your code, there's also this by coder. That is specifically if you want to use this inside of a storyboard. That's that more visual way of laying out the views. So it's not necessarily a bad thing that we run into this, but it is something extra that you have to know about with UIKit if you wanted to make a programmatic view. I think this should be good, so let's run this. Yeah, okay, so here we are from before. Now, if we want to mimic what we have here with 2 boxes, but we want to set the inner color and outer color, very similar to what we have here. So we'll do inner color, and this is a UI color, and then outer color, which is UI color, okay? Then we have to make our own constructor, okay? And because we're dealing with classes and we have this like super init that we have to do, we actually have to set our properties here first, because if those fail or crash, then we didn't call the super. I don't know, it's definitely a Swift thing to learn when it comes to classes and creating your own constructors. So let's see. Now I have to do inner color dot system red, and then outer color dot system blue. Okay. Should get the same thing. We do. Okay, great. But now I want to like do two of them. This is where it gets a little tricky. So I can't, as you can see, I only have one view I can set. So I can't like have two of them. So what I need to do is actually create this wrapper that we had before. And we have to create a wrapper for the wrapper. So I guess what I'm trying to say is that this is going to be rectangle. And then we'll do a rectangle too. Now, in order to get them stacked the way that we want, we're actually going to have to dig down to our stack that we had before. We call it a V stack. But here, this is how we have to do it in UIKit. There's a constructor already here for us to do our arrange subviews. So I'll do rectangle and rectangle 2. Okay. Again, with the programmatic views, set this property here, translates auto sizing mask into constraints. So it's false. And actually what we need to do in order to get it to line up exactly how we're expecting is we have to actually write some more layout code here. So let's see, constraints, activate. So this would be similar to what we have here. Let's just put it right there. But then we'll change this. And don't forget to add it as a subview. So we take the view dot add subview of the V stack. And the V stack contains the rectangle and the rectangle 2. And from here, let's see, we need view dot and view dot. Okay. I think this will give us similar to what we have before. Not quite. Forgot about this part. View dot background color equals system background. And we have two arrange subviews. There's the stack view. Oh, we didn't say how the stack view actually stacks. Is it vertical or horizontal? So V stack. I know I named it a V stack, but let's see. Is it direction? Direction. Vertical. Kind of guessing here. I'm not getting autocompletes working for me. Maybe it's axis? Yeah, axis. Okay, vertical. Let's see. Still getting just the 1 on the screen. It's a little bit trickier to debug than I wanted it to be. Let's see. So we have the rectangle, rectangle 2. Put 1 in here, put the other in here, set the axis. Do I have to set spacing? Stack dot spacing equals, I don't know, 2, like a little 2-point spacing. So not totally sure. The only way I could maybe guess how this is working is we have an option here to step through the code, and then there's step through slowly. So let's just step through the code, see what it does. I think it's going to highlight things on the left-hand side for me. Is it doing that? No? Okay. All right, well, another thing I could try is turning off the enable results. I know sometimes that slows down the calculation of re-updating the views. Yeah, see, that didn't work either. Let's see, what else is there? I think maybe just take these and stack view like so, and then the stack dot add arrange subview rectangle v stack dot add arrange subview rectangle 2. A little confusing here. Oh, maybe I see why. So I set these properties, but I never actually used them. So let's say this is the self dot outer color, and then this is the self dot inner color. Okay. And here we go. All right, so I am looking at the second one in the arrange subview. Oh, and so something I didn't realize, I totally forgot. This view, nothing is really showing where its position is in space. Yeah, so center of this view. Yeah, so probably what it should be is that this should be center of this rectangle. And then this outer rectangle should be, instead of like the centers, it should actually be the rectangle leading anchor equal. Okay. There we go. All right. So not quite as what you would expect to do one or the other. Now to switch we could do this. So as you can see, a little bit different. I think SwiftUI, for the problem that we're trying to solve now, and reusing views, maybe replicating a couple across the screen, there's really not a lot of code that needed to be written here to do that type of layout. And if you take a look here, we had extra code that we didn't anticipate writing. We have this view component, which, yeah, we've made our own custom constructor, but we also needed to know about like, where is it inheriting from, because it's a class and not a struct, and it's not following necessarily a protocol. So we are a little bit freeform on how it's set up. There's no convention on how the setup for the UI should work, so we've made our own private function called setupUI. And we use that to set the background and some of these other properties here. Ran into some issues though with the layout and couldn't really figure out why. Whereas it was a little bit more straightforward on the box that we made here. So all in all, the difference between our UIKit and SwiftUI, it's not just about less code, but it's a little bit more about understanding. And hopefully you got some tips and tricks really on both frameworks. The frameworks actually also can be reused. So if you did spend a lot of time, like how we were making this view component here, if you were doing that yourself, there's quite a few strategies you can go about for reuse. If you're doing stuff like this though, and you want to be able to reuse it in your SwiftUI, you will be able to do that. We're not going to necessarily go through that today's video, but that could be something we do in the future. So we have the native development, which we're using right now, just particularly iOS development, and so that's going to be UIKit and SwiftUI. Those are the two frameworks, and we use Swift, the programming language, to accomplish that. Another option is React Native. In React Native, it lends itself more to web technologies, and it's very similar to the websites that you might create with React for the web. And then there's Flutter, which is built by Google, and Flutter, very similar to Swift and JavaScript, or the way that you make websites, but uses the Dart programming language and allows you to then write once and deploy on multiple platforms as well, so iOS being one of them, but then you could also go to Android and desktop and web. So if you like this video, go ahead and hit the like button or leave a comment if you guys have questions. If you want to see more videos like this, let me know in the comments below. If you want to see some of my other past videos, which are more web development oriented, you can go ahead and hit the subscribe button or take a look at some of the history. Thanks for joining today, and have a good one. Bye.